Oh, hello. Here's week 9 lecture being recorded from my deck in my house in Cleveland as I prepare to get ready to go to a funeral later on. We need to just have a quick overview of what whole of life planning is, or life cycle costing. There's many terms for this, but it's basically trying to work out what's going to happen to a property over the entire course of its life. Now, within Australia, we tend to consider the minimum period of time for a whole life being 25 years. Although if you go to Europe and Britain and you've got some older buildings, then you'll often be trying to plan out to 50 years plus. Of course, the further you plan into the future, the more guesswork's involved and the more inaccuracy will creep into the projections. So obviously, doing 5 to 10 years is fairly accurate, but 25 years is pushing the envelope a little bit, but it's quite possible to do it. So let's have a look at what whole of life is. And the whole of life comes from creation of the building, from birth through its sort of like adolescence, middle age, then it reaches its old age, and then eventually it snuffs it, or is knocked down, or is repurposed. Okay, so there's end of life doesn't mean you're going to knock it completely down. So we need to understand what the future holds for an asset. It's very important for a business strategically to know what's going to happen so they can plan for it. When are you going to need to repair things? Minor and major things, but when you're going to repair them, that has an effect on operation of the building, shall we say, and on the financing that's going to be required. When you're going to refurbish the building, you get to mid-age. A building may have 3, 4, 5 refurbishments during its life, which bring it back up to modern expectations, performance levels, etc. So when do you think you're going to need to refurbish? That could be a sudden change in technology or a change in the market. But when we're doing life cycle planning, whole of life planning, we tend to tie that around major equipment replacements. So you're looking at probably every major refurbishment every 15 to 20 years maybe. You need to look at different utilisations and priorities. A building may start off as a high quality office building, but as it ages and maybe the demographics change, so the high quality office buildings have moved to a different area of the city, then its performance levels that may be lower to meet the market it now sits in. Utilisation, a building that may be heavily utilised will have an awful lot of repairs, a lot of wear and tear, whereas a lower utilisation building, things will last longer. Think of a carpet in a corridor. If not many people walk up and down it, it's going to last a very long time. If everybody walks up and down it every day, 7 times a day, it's going to wear out quick. And there's the environment the building's in. I mean, if you're in the middle of a CBD, that's one environment, but you might be right on the coast, exposed to the wind and the high salt content from the sea spray. You might be in the middle of the desert, experiencing extreme thermal differences and movements. So you have to look at the environment the building is in as well. And then, of course, you look at the history and past condition assessments to sort of get an idea of the patterns that are occurring. Basically, the whole of life or life cost planning, we're applying our extensive knowledge, our experience of the asset's performance and how it's degraded over time and what maintenance has been required to it. And that comes from the records, but also from our personal experience. Not just the inspectors and the people who analyse like me, but also from the tradies that work on the building and the maintenance records, etc. The process, well, it applies asset knowledge, and we use software to do this with. There's loads of different proprietary software systems out there. We model the degradation or the aging, how the building slowly declines, use of all the components, and when you take the total of the components you get the building's degradation. There are established degradation curves or algorithms that model this fall, they can be developed from the records of the building if it's old enough, by the way. And that gives you the condition of the building against the time. So as you go from year 1 to year 20, obviously the building's going to get a lower and lower condition rating. There will be little blips upwards in it as we intervene, and that helps us to produce a predetermined cycle of condition-based maintenance. The preventative maintenance is going at the same level all the time, because most of that's legislative, but the condition-based, yeah, there's a cycle to it. Okay, we have to calculate the cost of these maintenance works, etc. So the life cycle profiling or planning accounts for all the physical, functional and financial variables that impact on an asset, including future risks. I mean, obviously no one would have foreseen the COVID thing, but so that's roughly what it is. We're looking in a crystal ball, very well educated about what's going to happen next. It's a process, okay? There is a set process and set stages to this, and it applies that knowledge we've got of the assets, how they degrade, when they need maintaining, and the costs. So it applies those in a process format. We need to understand what the current condition and state and performance levels of an asset is, and where they need to be in the future. Now they may be the same. If you've got a theatre, then the standards now, apart from legislative changes that might increase the standard in certain areas a bit, like disabled access, etc., will be the same in the future. Technology might make an effect on this as well. But all this needs us to understand these factors. We need to understand them in a lot of detail. We do look at them in this paper, or should I say presentation. Now if we take these factors into account, then the process of the planning the results that you get provide information that the management requires, strategic and everyday operational management requires to run the facility. Okay, so we come back to the strategic asset management plan element is tied in here. Aging, how do things degrade and age? Well, even with an established maintenance program going on, most organisations cannot identify their long-term budgets and requirements to maintain the performance and condition levels of their assets. They can't do it. It's not a core skill set in most organisations, and normally gets outsourced to supposed specialists, and you need to be careful who you pick for this. Just a drink of coffee there. We know that the older an asset is, the more expensive it is to maintain. Okay, so older ones are more expensive, just by the nature of them. Like old people are more expensive to maintain with all their healthcare. The higher the utilisation of a building, the harder we use it and beat it up, the shorter its life's going to be. More interventions are going to be required. Each of the parts of the asset will degrade differently. Front of house will degrade differently to back of house. Certain mechanical equipment may not be heavily utilised, but other equipment may be utilised and age differently. Air conditioning for an ordinary office, air conditioning for an operating theatre, they're obviously going to age and fail at different rates. Different bits of an asset have to require, going to work at different levels of condition. So, if you're in a storeroom or back of a house, then you can have assets that are quite happily working, but if they're more critical, or they represent the quality of the business and the public can see it, for example, they might be kept at a higher condition level, even though they can run at a lower one. You've got to be careful you don't have too much or too little maintenance. Okay? Because if you put too much maintenance in or too little maintenance in the long run, it's going to be uneconomical. You need to hit the sweet spot between the two. Corrective maintenance, or correct maintenance, is really aimed at optimizing the performance of the asset, minimize its running costs, and retain its value, or extend its life. Okay, so good maintenance aims to do that. You're trying to stop things breaking down, failing, and needing replacement too often. Primary objective of our life cycle planning is to prepare a logical, justifiable budget for the maintenance and capital replacement of the assets in the facilities. And if you take all those assets in one, that also means of the facility itself, and we aim for about 25 years. Okay, if a detailed approach is taken, then this is going to detail works programs that identify future maintenance and capital replacement tasks out to the 25, maybe beyond that years, and you will see that there is a cycle. So when you get a peak of maintenance requirements and replacements, that might trigger you to think of doing a refurbishment at that time. So you're trying to group things together in packages and minimise the disruption that can occur. Now, when we link this plan into a condition assessment process, which we've looked at, then life cost planning establishes a consistent approach across all the assets, and the condition assessment captures the asset knowledge that is often lost in an organisation. I mean, it might be that important people leave and they take the information with them because it's not being recorded or captured, and or it can be transferred from one organisation to another. It can be used to benchmark yourself against your competition. Now, whilst it is actually on paper, it looks like a very simple process to do. It's actually quite difficult, and the difficulty almost exponentially increases with the complexity of the building. So if you're doing an industrial storage shed, and you compare that, as you've done in the recent assignment, you compare that to a hospital, the differences are immense, and the complexity is immense, and it becomes much more difficult to do for many reasons. So you end up with more components degrading at different times, different conditions. I mean, the variables that influence asset life generally, we would say. That's why we use software programs to help us collect the data and then crunch the numbers and analyse that data. Without computers, we really wouldn't be able to do it to the detail and accuracy that we do nowadays. Although this was done manually in the past. Although did rely on individuals' knowledge who stayed at an organisation their whole working life. So it helps us do the modelling and the degradation curves, etc. I am aware that there are many software programs available to support this process. Many programs. These systems generally have data management software within them to help us record and manage all of the asset data, and they all contain libraries of components already in the system for you to select, which give you the lives and the maintenance requirements, etc. They'll include all the statutory maintenance. So if you pick fire hose, these systems will know that a fire hose lasts whatever number of years. It's got a 6 and a 12 monthly maintenance requirement to it from legislation, so it automatically plans that into your program. You don't have to put it in, it's in there already. And the condition rating you give to that hose will then, the system will take that and it will calculate when the replacement is based on the condition when you looked at it. So it's all automated for you. Somebody does have to do a reality check over it at the end, but they're normally pretty accurate. So most systems will actually generate the budgets, they generate the maintenance programs. But remember, with computers, you put rubbish in, using bad inspectors, bad information, you get rubbish out. So bear that in mind. Now, there's some steps to undertaking the process itself. First of all, you've got to know what you want to achieve by doing it. It's a lot of effort, and it's a costly exercise for a client to do. My coffee's nearly gone cold. Hang on, I'll finish it. That's better. So it's expensive to do. So you need to know what you want out of it at the beginning before you do it. So an example would be, it can be applied at a very high building level. So we might only look at a floor as a total, not individual rooms. We might look at a building level, just the building itself. If there's repetitive buildings, Department of Defence, they've got a lot of repetitive buildings. We look at one and then we can just apply that to all of them, and it's pretty accurate. Or we can drill right down to every single building component. That's when we would actually create an asset register of everything. Of course, the more detailed you go, the more time it takes, the more expensive it gets. So there's a balance between that, and mostly clients don't quite understand that, and they need to be educated and their hands held. That's often why we do a pilot study, remember. But whether you're doing a high level or a really detailed one, the output basically determines the input that's needed. So the level of information that's required is this. If you're working with, say, a statewide complex, a government department portfolio, and you're looking for 25-year funding models, as state treasuries generally like to see, that could be developed using a number of high-level indicators, using, for example, the repair and maintenance costs over the replacement value of the asset, and many other indicators that you could use, but high level without actually inspecting every element. If you're working only a facility, a single building level, you would tend to go a high level review of the site and collect asset information. So you'd look at service delivery functions, you'd look at the ages to be able to work out the 25-year budget and to prepare for the whole facility. But you would be looking at large assets. You'd go air conditioning, done. You wouldn't go down to compressor, pump, chiller, valve. You wouldn't do that. This would be just, there's an air kitchen, there's a lift, there's a floor covering on this floor. If you're working at a building component level, which some clients want, and it's worth doing once in the life of the asset, just to establish that asset register and detail, this is where you're going to do a lot of condition assessment programs are focused in this level. Clients pay through the nose and then don't know what to do with this level of detail. But this detail gives you a 25-year budget, can give you a works program, a maintenance program for anything from 1 to 5 years to 10 years, and it can help identify where refurbishment periods are going to occur. So you've got to be careful. You don't want to do detailed inspections if you don't have to, because it's going to cost a lot of money and it's a headache. And many companies think they can do it, and they actually can't. Once we've got past that, we know why we're doing it and what level we're doing it at, then we've got to identify the assets that we're going to model, we're going to look at, and what factors are going to influence our modelling, and what's impacting on the degradation rate and the renewal schedules of the sub-elements. So some of the following factors will influence these considerations. So the required condition standard of a facility, which has to be agreed by the client, should match the importance of its service delivery and the requirement to achieve the appropriate fitness for purpose, safety, etc. That's going to influence when the building elements are renewed or replaced. So you wouldn't apply the same condition standard to the floor coverings and paintwork in a store cupboard as you would to the manager's office. So next, how heavily is the building used? What's the utilisation of this facility? Is it a 24/7 building, or is it just a 12/5 building like most offices are? That's going to influence the rate of aging, the rate of wear and tear. And that might vary. You might have bits of the building that are 24/7 and most of it isn't. So you'd end up with splitting two sub facilities almost. What are the facility attributes? What's the age of them? What's the building complexity? Is it heritage? What's the presence of anything nasty like asbestos, lead paint, lead pipe work, anything like that that might influence the required level of maintenance and the capital replacement expenditure? God forbid you find asbestos. The rate of external facility degradation, the walls, the roofs, within the state of Queensland, we'd say, because I know that quite well, is going to vary on its location. So coastal versus country, temperate down Brisbane, tropical up to Cairns, etc. They're going to have completely different degradation and ageing profiles for the same material on the same type of building. Then you've got the cost of delivering any type of maintenance. Okay, that's obviously going to need skilled labour and materials, and the market rates and the day rates for these things vary geographically immensely. So obviously, if you're going to do work in a main city, probably your rates aren't too bad. They might be pushed up if there's a lot of work and competition at the time. Maybe a natural disaster's occurred and they're rebuilding, then rates will go through the roof and materials are hard to get. But then again, if you're trying to work remotely in the middle of nowhere, or try to ship materials and tradespeople to, say, Thursday Island, as I once had to, it was costing 3 times the price. So the location, and that's going to have an impact on your costs. And then you've got to identify the asset attributes and the current level of performance and condition today, and what they want to be in the future. What's the required performance and condition at a future time? That's a little crystal bally sometimes, because the use of the building and everything could have changed by then, and you have to reassess. This is not a static model. This model can be updated at any time. There's a lot of effort required at this stage to determine what's happened in step 1 and step 2. So if a detailed life plan is required by the client, and the physical attributes of the assets and that, and its design, its materials, its utilisation, that have to be identified. That might include a condition assessment of the current condition as the base point to start from, and you identify the quantities of these elements, square meters, number of, etc. And then you can degrade those over the next 10 to 25 years. If the facility or building is absolutely new or still on the drawing board, then really only the sub-element quantities are required and their condition is assumed to be new. I did that for a jowl some years ago, where we worked out the 25-year whole of life program for it based off the bill of quantities and the drawings, and we actually came up and made recommendations to change things, because over the 25-year period, if we changed the type of floor covering, the soap dispenser, the whatever, it actually saved millions of dollars over 25 years, because you didn't replace them as often. So just the variables, so you need to be aware of the variables that can affect your condition ratings and your outcomes, etc. The asset utilisation we mentioned, utilisation of the facility, it's determined by the period of service delivery. It's an indicator to the wear and tear on the interior building elements and finishes. Okay, so the more people are in and out, the more functions, the more walking around, the more activity, etc. That's heavier utilisation. A library has low utilisation. Not many people walk around them, and they walk slowly and silently. But then if you've got, say, a school with lots of kids running around, that's got quite high utilisation. Then there's the asset standard, the required condition standard, or asset standard sometimes called, that is assigned to a component. Isn't just a number, it'll define the minimum condition it's allowed to degrade to before it needs replacing or major maintenance. There's the work cost factors that we just talked about difficulty of getting skilled tradespeople, materials, and you would have touched upon that in your last assignment for the historic bank building. That applies in real life. You might be in a city or remotely on an island. We just touched on this. The same thing goes with the regional cost factors. It can cost a lot more if you're in the regions than in the main city centres or urban areas. Exterior elements, the environment's the main difference you've got to be aware of there. The environment can actually make a big difference to the estimated life of say wall cladding. Okay, generally warm marine exposure shortens asset life, and cool, arid, desert-like areas lengthen it. And the whole process requires the physical environment of the components in a facility to be clearly understood and identified, because that determines how often you're going to restore them, replace them, or intervene with major maintenance. So you need to understand them heavily. So basically, I used to work at GHD. I used to work with a bloke called Larry Woodland, and he wrote a paper that I've based this presentation on the paper that he wrote. So I actually, doff my hat to Larry. He's extremely experienced in this field. Nice bloke as well. So thank you, Larry, for this. And that's generally it. Okay, so I hope you enjoyed it. I'm now just going to finish off week 10. Week 10 will be our last presentation. Okay.